Welcome to Chillin' 101. We hope this video helps.
You start by finding the domain and the first actionable critical points. First, scan the formula for division by zero, even roots, or log restrictions so you know allowed x values. Then compute f, x, and solve numerator equals 0. Also mark points where f is undefined. These critical points and any domain and points partition the real line into intervals. You do this so that subsequent sign tests are reliable, and you avoid testing invalid x values. Once you have intervals, pick a simple test x in each open interval and evaluate fx to determine its sign. If f test 0, the function is increasing there. If f test 0, it is decreasing. Make sure to handle vertical asymptotes or removable holes separately because they can flip behavior or invalidate an interval. Also compare one-sided limits at endpoints when needed, since the behavior just left versus right of a point can differ. Finally, assemble your results into a clean list of intervals where f increases or decreases, merging adjacent intervals that share the same sign of f. Make sure to mark endpoints as open or closed according to domain membership and continuity. If the function is undefined at an endpoint, leave it open. Double-check by sketching a quick graph or testing extra points near boundaries. If results disagree, re-evaluate derivative algebra.
Thanks for watching. Consider subscribing if we helped you.